Let's take a look at this problem. The nice part about this problem is you're already given us a picture, a figure of this solid. So I think that even this figure is not given, you should still be able to solve this and then also mentally picture what this looks like. All right, let's take a look at this problem. The base of S is a circular disk with radius r. So maybe I'll try to draw a little so to help you. So actually the base is actually a circular, kind of like a circle, a perfect circle. Or maybe if I draw a graph here, I'm going to talk about that real soon. And then parallel cross sections perpendicular to the base are square. So like these are the cross sections that are perpendicular to the base. Well, the trick is you always want to find a way to place, to impose this guy to a xy coordinate. So here's what I would do. Here's the hints that I have. Because of the graph is given like that, so I'm gonna say, hey, this is one of the diameter, okay? So this is a diameter. I'm gonna call this as x. And it's very intuitive to place the center of the base to be like coincide with the origin. So say suppose this is the origin and this is the y. And in other words, the base looks like this. A circle, right? A circular base. And here the radius is r. So in other words, like this distance from here to here, this is the r. So in other words, this is r and this is actually the negative r. With that, you can quickly figure out, oh, by the way, let me continue to draw. Say, suppose this particular slice, this blue slice, like this blue slice is somewhere here, right? So it's corresponding to this guy. Of course, there are many slices. So these are the slices. It's supposed to be vertical slice. So I hope that kind of will help you get started. So now, because this is a circle, I'm gonna say this x squared plus y squared should be equal to r squared, meaning y squared is equal to r squared minus x squared, or y is plus or minus square root of r squared minus x squared. Okay. Now, when this slice is, let's say this is an arbitrary slice on the base, which somewhere here there's a slice, and above this guy that's a perfect square. That's a square. Okay. So in other words, I just need to figure out. So therefore, I'm gonna say, therefore we make a vertical slice. The width is dx, and then from negative r to r, because this slice can range from negative r to r. Now here, this is supposed to be the cross-sectional area, which means the area of this square, if this square is the corresponding slice of this particular one. So therefore, to find the area, we need this length, right? So we need this one and then square it. We need this one and then square it. Because it's a square, so just this length and then square, then you get the cross-sectional area. So now, what is this length? We already have we already solved for y, so there's a plus or minus. Obviously, the plus corresponds to the top, the top half of the circle, and when you have negative sign, that's the bottom half. So in other words, the top is y equals square root of r squared minus x squared, where this, what is x? X is the location of this slice. And the bottom half is y equals negative square root of r squared minus x squared. So what is the distance from here? What is the length of this slice? the top minus the bottom, right? So this guy minus this guy, well, this minus the negative of itself, it's going to be double. So therefore, I'll have pi, the square of this guy, right? 2 times square root of r squared minus x squared, and then square, because it's a square. It's a square, therefore the area will be square of this length, and this is the length, this guy minus this guy, which gives you 2 square root of r squared minus x squared. And this is my hint. So I feel that from this point on, you can take advantage of the symmetrical property of this integral, because the integrand is a even function. So that's why this doubles, reduce to 0 to r. And it will not be too difficult to evaluate this integral. It's just the square will get rid of these square roots. So it will be something that I would like to let you to complete.